In this video, let us see how to create the real-time face blur effect using Python. So let me show you the demo first. Consider I have a Python script here. Let me run this Python script so that if you open up the camera and it will have a real-time face blur effect inside the camera. So let me run the Python script now. So Python main.py is our file name. Consider now our camera has started and you consider here we have a real-time face blur effect. And if I tilt the head also, the blur effects remains the same. And if I remove the spectacles, the blur effect is remain the same, right? If we are using the media pipe to detect the face accurately, so let's see how to create the real-time face blur effect using Python. So let's install the dependencies that we need for this project. So open up your command prompt and type pip install. We need the OpenCV Python and we also need the media pipe. So using the media pipe, we're gonna create the full frontal face detection as well as the side face detection. So let's import the libraries that we need. So import CV2, that is the OpenCV Python, and we also need the media pipe. So import media pipe as MP. First, let's initialize the face detection. Media pipe, that is MP face detection, is equal to mp.solutions. So inside the solutions, we have a file called the face detection. So we'll have to access that. So that is the face detection function. Now we have the face detection, right? Let's also create a drawing. So mp drawing equal to mp.solutions.drawing details. So we also need to have a blur effect on the camera, right? That's why we need this. Let's define the camera. So camera equal to cv2.video capture. So inside this we have to pass the camera number. So if you are having a default camera, you can pass 0. So if you are having a multiple cameras, we can pass 0 or 1 or anything. So I'm having a default camera, that's why I'm passing 0 here. So what we can do is we can use the face detection object now. Here we have a face detection, right? We can create a face detection object now. So with face mp face detection inside this, that is the inside this we have a class called the face detection. So call it class, so face detection, and inside this we have to pass these subparameters. The first one is the model selection. Here we need to pass 1. So the 1 means we have to detect the face from the longer range. If you want to pass 0, you can detect the faces in a wide shorter range. So here we want to detect the faces in a longer range, so pass 1, and also pass the minimum detection confidence, and we're gonna set this confidence to 0.5. That's it, and we're gonna open this as face detection. Now we have the face detection object, right? And we have created this face detection object on these parameters. Model selection is equal to 1 and minimum detection confidence is equal to 0.5. Then what we can do is we can have a infinite loop and we can continuously check the frame. So let's try to do that now. So while true, we're gonna continuously take the frame now. So we're gonna use this camera object. So this camera object will return two values. That is the frame as well as the image. That is the frame is either success or failure. So camera dot read. So if the frame is not success, that is if we got any error while capturing the frame. So if not frame, then we're gonna simply break up the loop. So simply we can break the loop now. Yes, if you have the image captured successfully, then what we can do is we have to convert this BGR image. Normally, when using the OpenCV library, it will capture the image in the BGR format. We'll have to convert this to the RGB format because the media pipe will only take the RGB images. So we have to convert this BGR image to the RGB image for the media pipe. Let's do that now. So image RGB is equal to cv2.convert color, and inside this pass the image that we want to convert to, and let's also define the BGR to RGB. So cv2.color. Here we have a BGR to RGB selector. Now we have the image in the RGB, right? We can pass this image to the media pipe object. That is the face detection object that we have defined above. So let me comment detecting the faces. So results equal to, we're gonna use the face detection object dot process. So inside this process, pass the RGB image, that is image RGB. Now we have the results, right? The results will contain the face detection. So first we will check if the results have any detections. So if results dot detections, then what we can do is we can look to individual detections. But because if you have multiple faces, then we will have individual things. That's why we are looking through. So for detection in results dot detections, here what we can do is we have to first select the face box because the blur effect has 4 coordinates, right? X, Y. So let me show you what I mean. Consider here in this blur effect, you consider we have 4 coordinates. So this is the first coordinate X, and this is the Y, And if you add x plus width, we will get this coordinate, and x but height will give this coordinate. So we'll have to get these 4 coordinates. So face box equal to, first we can get the relative bounding box. So direction dot location data dot relative bounding box. This will give us those 4 values that is relative to the that image only. So we'll have to convert this into one pixel values. So we can extract those 4 values from this face box variable. So h comma y, first we need the height and width. H comma w comma channel is equal to, we can get this values from the image dot shape. Now we have the height and width. Then what we can do is we can extract the x value. So to get the x value, we can use this face box variable. So face box dot minimum x, that is x min, and we'll have to multiply this with the width, and we'll also have to calculate the y. So y equal to face box dot y min, and we'll have to multiply this with the height. So let's also convert this to the integer so that we don't get any error. Let's also wrap this y to the integer as well. Then we need to get the box width. So box width equal to, let's also convert this to integer. So face box dot, we can get the width now. So width face box dot width, and we'll have to multiply this with the actual width. And we can also get the box height. Let's also convert those to integer. Face box dot height, let's also multiply this with the h. That's it. Now we have the 4 values, right? Then we'll have to make sure that these 4 values are within the range. So and so the coordinates are within the range. So make sure that the no values are out of boundary. So to do that, what we can do is we can use the max and min function. So x comma y is equal to, so we can take the max value of 0, either 0 or x. Let's also do for the y as well, max of 0 comma y. So if the x values are negative values, we will take the simply 0. That's what we are doing here. Let's also do the same for the box width as well as box height. This time we will take the minimum. So minimum of w width comma x as well as the box width. So this will make sure that all the 4 values are within the boundaries. Now we have make sure that the coordinates are within the range. Then what we can do is we can simply create the blur effect. So blur the face region. So face region, first we have to get the face region. Now we have the 4 coordinates, right? Using the 4 coordinates, we can only get the face region only. So for this, we're gonna use the image. So inside this image, we're gonna use the slicing. We're gonna use the slicing for y up to the y plus box height. Let's also use the x. So from the x, we're gonna go up to the width. That is the box width. Now we have the face region, right? We can simply blur this. So blur face equal to, we can use a Gaussian blur. So CV2 dot Gaussian blur. So we're gonna apply the Gaussian blur on this face region, and we can simply replace the original face with this blur face. And let's also define the size of the blur 91,91 and sigmoid x. So further we gonna pass 0. Now we have the blur face. We're gonna replace this blur face with this original face region. So we gonna, here we have a original image, right? That is, here you have a original image. You have a original image. We can simply replace that original image face region only with this blur face. Let's do that now. So image of the same thing. We're gonna start from y up to the box height. Let's also start from x up to the box width. So x up to the box width, x plus box width. This will be our blur face. So now that's it. Now we have replaced the face region with the blur face. Then what we can do is, if the face is not detected, then what we can do is we can simply put the text like no face detected. So CV2 dot put text, we're gonna put the text on the image, and the text will be no face detected. And where we want to put these text, we're gonna put this on the coordinates 20,20 and the font size. So the font will be the Hertzley complex. From Hertzley complex, font Hertzley complex. Then font scale, we're gonna pass 1, and font color, so I'm gonna pass the red color 0,0. That is the RGB values, and that's it. Let's also display the result. So CV2 dot image is show. So we're gonna show the image on the window called the face blur window, and we're gonna simply show the image. And that's it. Finally, what we can do is, if the user anytime press Q, we'll have to stop it. So for that, we can use this two lines. That is, the user some anytime press the Q, we will simply break out the loop. And finally, what we can do is, we can release all the resources that we have taken. And we have taken the camera, right? We can release the camera. So camera that release, and we can also destroy all the windows. So cv2 dot destroy all windows. So that's it. These are the 62 lines of code that we need to create a real-time face blur effect. Let's try to run this Python script now. So let me copy the Python file path, and Python, let me run the Python file now. So let me press enter. So just give a few minutes. It will take some time to open up the cv2 camera. Here we have the cv2 camera. Now even if I tilt the face, it will accurately detect the face because we are using the MediaPipe. The MediaPipe will automatically detect the frontal face as well as the side effects. To consider, even if I remove the specs, the blur effect is still stays the same. We consider, and even if I put the spectacle again, it detects the blur effect. And yeah, this is how you create a real-time face blur effect using Python. So this is for this video, and I will continue in the next one.